So, good evening, students. So, in last class, we have just started that finite potential, and we have seen that how we can go for the even function as well as odd function. So, in last class, I have just derived all these condition. So, this is the condition, and this is due to boundary condition that my wave function must be continuous as well as differentiable at x is equal to a by 2 or minus a by 2. And here we are just making it dimensionless. You remember that thing. Suppose our potential is something like this will be minus a by 2 and a by 2. So I have to multiply with a by 2 on both sides. So why we can get the new parameter eta and xi. Suppose my potential will something like this one. Maybe in the examination they will ask you that this will go to minus a to plus a. Then what you have to do? You have to just multiply it by a itself, because it is nothing to do with the width. So don't think about width. You have to just take the at which coordinate you are taking the boundary condition. If you remember in last class, we are doing the exactly same thing. So what we will do, we will just multiply with a in this case, but here it is a by 2. So we are just going to multiply with a by 2. So right now we are just solving this whole thing for this particular potential. So why I have just calculated. And if we are going to calculate eta square plus xi square, then it will be mv naught a square upon 2h cut square. You can easily calculate. Just multiply a by 2. Just multiply a by 2. Take the square. Then you can find e term will be cancel, and you have 1 by 4 is there. Then 2 and 2 will cancel. You can easily get this particular thing. So now what we have to do? We have to solve these two things. One equation this, second equation this. Theoretically, you can easily solve it. What you can do, you can put the value of eta into this equation. So I can put the value of eta. So this will be eta square 10 square xi plus xi square is equal to mv naught a square upon 2h cut square. So if we are going to solve the value of xi, we can solve actually value of k into a. And once we are solving the value of k into a, we can easily calculate the value of e. So theoretically, we can easily solve this equation. So there is not any problem. But solving this equation without use of computer is next to impossible. You cannot solve it without using computer. Right now, you can easily solve. You can write this equation and you can easily solve this thing. So how we will approach this problem without using the computers and numerical analysis? So we will use what? Graphical method. So here we will learn to solve the problem with a graphical method. Listen, the solving quantum mechanics is one of the toughest tasks. Only one system, that is particle in infinite box, you can solve with the first principle. And other any problem, you have to take lot of approximation. Sometime you can just you can just find the only eigenvalue. Sometime you can find the number of possible eigenvalues, and this kind of constraint is always there. So why quantum mechanics is really tough subject? Because even using the mathematics for the approximation level is not going to work. So why each and every problem we will try to solve up to a certain limit. So here we are just going to solve it with the graphical method. Solving the graphical method means we are just trying to see how many bound states are possible and how we can analyze the different types of bound state. So this is the actual thing. So I am just giving you one example how we will solve the graphical method. Suppose we have equation sin x is equal to ln x. Suppose we have equation and someone will ask you how many solutions are possible. Then how you will solve it? You will just write y is equal to sin x, and you will just write y is equal to ln x. And what you will do, you will just plot these two functions in a same axis. So we will just plot y versus x. So first we will plot y is equal to sine x. So it may be this kind of situation into first quadrant. And then you can plot y is equal to ln x. So y is equal to ln x have something like this plot. And what will happen? The solution is this particular point where these two curve is going to coincide. So you can easily find, and at least we can say what should be the range of value, what should be range of x, and at least we can say how many possible solutions are there. Suppose it will cut at 2 point, then you have two possible real solution. But here you can have only one solution because it is going to cut at one particular point. So we are just going to use this concept to graphical method, and we will just try to figure it out how many solutions and how many bound state can be possible. So if you have any doubt, you can just ask me. Otherwise, I will just try to solve it with the graphical method. Okay. So we have two equation. First equation is eta is equal to xi tan psi, and second equation is eta square plus xi square is equal to mv naught a square 2h cut square. Now this equation, so first we will plot eta versus xi for this one, and then we can plot eta square plus xi square. You can think that this value is for the given value of a and v naught, this value is constant. So I can write this value as something eta square plus xi square is equal to, let's say, r square, and this is nothing but the radius of circle with the eta and xi. We are going to solve it. What is value of r? The value of r is all about m v naught a square upon 2h cut to the power half. So I am just going to solve it for the generalized value. And now please mind it, eta and xi both are number. So it is very easy to solve, to analyze, because we are making it dimensionless. So how we will just go for it? It is very interesting thing. And we are just solving for the even case. Then we will go for odd case also. So this is all about eta versus xi. And eta and xi both are positive, so we will just go for the one particular quadrant. So the one first quadrant we are just talking about. So if we are saying eta versus xi, this tan xi is going to dominate on xi, because this is slowly varying, and this will be very fast going to infinity. Even if when you have xi is equal to pi by 2, it is going to infinite. So more or less this equation will just give you flavor of eta versus tan xi. So what should be the solution? That the particular curve is all about this. So it is going to, at this pi by 2, it is going to infinite. The second branch will be start from pi. This is 0. Obviously this is pi by 2, and this is 3 pi by 2. You have infinite, and third branch you have at 2 pi, and so on. So you have different branches. And now what should be this equation? This equation is nothing but equation of circle. And how much bigger circle is there, it will depends what will be r, and what is the value of r will depend what is the value of v naught actually. So for the given value of r, we can have different circle. So suppose I just want only one even state. I just want only one even state, means one, what I want to make the condition that we have only one even state. So for one even state, what should be the value of r? What should be range of r? Obviously it should be between 0, this should be greater than 0 and less than pi. Because if we are have this particular kind of situation, suppose it will be greater than pi, then it will cut at the 2 point. So we need only one event. Means I want something this kind of situation or anything like this. Will we just tell you about only one event state? So what should be R? The range of R will be between 0 and less than pi, isn't it? And this point, so this is eta and this is I. So this point will tell you what should be the value. So you can easily find this is between 0 to pi. This is all between 0 to pi. So you have this also value. You can have this particular value. You can have this particular value. You can have this particular until you are not touching the pi, you will not get the second bound state. So you have only one bound state. And what should be condition for two bound state, two even bound state? Can anybody tell me what should be condition of two even bound state? That will be 0 to 2 pi or pi to 2 pi?
Pi to 2 pi.
0 to
Exactly,
2
that should be
pi.
no, because the answer will be between pi to 2 pi. Why? Because what we want exactly two bound state. So if you will take 0 to 2 pi, means you can take the value 0 to pi also. And between 0 to pi, you have only one bound state. So 0 to 2 pi will tell you the condition that you have either one bound state or two bound state. But if I am asking that you need only two bound state, means you need higher energy, and higher energy means your energy will be between pi to 2 pi. Are you getting this? Because a lot of people have confusion into this particular thing. Why I am taking pi to 2 pi? So if this kind of situation is there, then you have two bound state, and this will be your one and this will be your second. I am not writing right now ground state, first excited state. Once we will do the odd part, then we will combine all this and then we can talk about this. So what should be the three even bond state? What should be three even bound state? Can anybody tell me?
2 pi to 3 pi.
Very good. That
2
will
pi
be
to 3 pi.
very good. That will be 2 pi equal to 2 pi and less than 3 pi. So naturally you can go for next level of calculation. Okay. So this is all about even case. Same way we will go for odd case. If you have any doubt, you can just ask me. Otherwise, I will go for odd case also. Okay, so let's go for odd case. So don't worry, we will just do it again when we will do the odd case, and then we will merge even and odd case, and we will give the complete picture of the solution. Okay, so let's go for odd case. Okay, so let's go for, so what will be my potential? My potential is something like this. So this is minus a by 2 to plus a by 2. This will be your V naught. This is region 1, region 2, and region 3. Again, psi 1 is equal to a e to the power gamma x. You remember all this thing? X is less than minus a by 2. The psi 2 is all about, we can write, let's say, b e to the power ikx plus c e to the power minus ikx, because it is free particle. So this will be minus a by 2 to plus a by 2. And let's go for psi 3. That will be d e to the power minus gamma x. X can be greater than a by 2. So obviously for the odd case, we can just use this particular thing. What should be the odd case? Psi 2 minus x must be equal to minus psi 2x. Same thing what we have done into particle in infinite box. So what we have b e to the power minus ikx plus c e to the power ikx must be equal to minus b e to the power ikx minus c e to the power minus ikx. What should be answer? So b is equal to minus c. This is the value, isn't it? So b is equal to minus c. So again, we can write the psi 2 is nothing b e to the power ikx minus e to the power minus ikx. We can write this whole thing as, let's say, so a ho gaya d, let's say it is f. You can write f sine kx. So this is my psi 2. Now what we will do, we will again go for the boundary condition. Same boundary condition we are getting here. So what should be boundary condition? The wave function must be continuous as well as differentiable. So the first boundary condition, psi 2 at x is equal to a by 2 must be equal to psi 3 at x is equal to a by 2. So you can get the value f sine ka by 2 must be equal to d e to the power minus gamma a by 2. What will be the second boundary condition? The second boundary condition, it should be differentiable. So you can just take d psi 2 upon dx at x is equal to a by 2 must be equal to d psi 3 upon dx at x is equal to a by 2. What you will get? I'm writing here. Okay. So first you have to differentiate, then you have to write this value. So this will be f k cos ka by 2 must be equal to minus gamma d e to the power minus gamma a by 2. So you have this equation, and second equation you have this equation, isn't it? So what you will do? You will just divide. So this is your second equation and this is your first equation. You are just going to divide it, then you can get the next boundary, next equation, and that equation I can write. I am just dividing equation 2
सर नीचे क्या लिखा
divided by
है
equation 1. कहाँ पर ये?
सर नीचे लास्ट में जी, इसके नीचे ब्रैकेट के नीचे
अरे equation 2 यार, equation 2.
सर दिख नहीं रहा है
Okay, sorry, equation 2, equation 2. Okay, equation 2 by equation 1, just जैसे पिछला बार किया था, है ना?
यस
So what you
यस
will get? You will get k cot ka by 2 is equal to minus gamma, isn't it? What should be next step? Can anybody tell me? What should be next step?
Make it dimensionless.
Dimensionless.
Make dimensionless by multiplying what?
A by 2.
A by
A by
2.
2. Very good. You can see this is very relevant thing. If it is A, then you have to multiply with A. But it is A by 2, then you have to multiply with A by 2. So just go for A by 2. Okay. So again, you can have eta is equal to minus xi cot xi. Don't worry. If you have any doubt, you can just ask me. Then again, we will go for the graphical method. Very simple, straightforward. Okay. Now, what we will do? We will again find eta square plus xi square. So again, eta square and xi square will be same. Eta square plus xi square is again mv naught a square upon 2 h cut square. And this thing I am writing r square. So in each and every problem, you have to define what you have to find what is r. And r will be just a number. Remember. Don't worry, when we will solve the problem into next class, you will see each and everything. So R will be just a number because these two are dimensionless. So what we will do? We will just go for basically the graphical method. Again, same thing. We will just plot it, this and this. So let's go for graphical method to solve this thing with the graphical method. Okay. So again, we will just go for eta versus I. And don't worry about this minus sign. Obviously, if this minus sign will come, then this will come into this side, but they are symmetric. So I am just talking about this thing because we have to just working for the magnitude, nothing with this minus sign, nothing to do with minus sign, because the magnitude wise, both will be same into every quadrant. So let's go for this thing. So obviously it will start from where? At pi by 2, it is 0, isn't it? So it will start from pi by 2. Then next is 3 pi by 2. Next is 5 pi by 2. Now you can see it's a very interesting. The value of R for one bound, one odd state, R must be at least the value of pi by 2. If your value will be less than pi by 2, you cannot get any odd state. So what will be condition of R such that you have only one bound state, only one odd bound state, only one odd bound state. What should be value? What should be the value of R? I am just talking about this kind of situation. The minimum you will start to getting the second bound or you will start to getting the odd bound state when the value of R will be pi by 2. So obviously the R will be between, so R will start from pi by 2 and less than 3 pi by 2. Isn't it? What should be condition for two odd bound state? What should be condition? Can anybody tell me? This is this kind of situation. So that will be start with 3 pi by 2 to 5 pi by 2 and so on. So you can just separately talk about odd state and even state. But don't worry, in the examination, they will not ask that tell me about odd state separately. They will not tell you about tell me that even state separately. No, you have to just analyze the whole system together. If you have any doubt, you can just ask me. Otherwise, I will just give you the complete solution. And next 5 minutes is the most important thing, that how you will proceed into the examination and what you have to calculate into examination, because in the examination you cannot solve this much of calculation. Okay. Okay. So if you have any doubt, you can just raise your question. Otherwise, we will go for the complete information of this thing. Yes. Okay. So let's go for the complete information. And this is all about symmetric potential. And this is symmetric finite potential. Now, so first thing you have to calculate what is value of eta square plus xi square. This thing you have to calculate. I am writing it generalize r square. And please, this is a number, some number 1, 2, 3, 4, 5, 6. This is the sum number. So first thing what you have to calculate, eta square plus xi square is equal to r square. What is second thing? Second thing, we have one boundary condition that eta is equal to xi tan xi. This is for even case. And next one, eta is equal to minus xi tan xi. This is for odd case. So what I am going to do, for the even case, I will take the solid line. For the odd case, I will take the dotted line. Okay,
कोट
I will
जाई नहीं
just take.
आएगा सर इसमें?
Please mute yourself. Don't unnecessarily unmute.
हेलो सर,
Okay. Yes.
कोट जाई नहीं आएगा
Sorry.
ओड
Minus
वाले
minus
केस में?
minus cot. Minus cot. Sorry. Minus cot xi. Minus xi cot xi. Good. Thank you. Okay. Now you will just plot this all thing, something like this. And this thing you have to remember for the problem solving. What you have to calculate, what value of eta square plus xi square in each and every problem. So this thing you have to calculate each and every problem. This will be always there for the even case, and this will be always there for the odd case. So you will just go for eta versus xi. I am just using the different color for odd. Okay, this is yellow one. Okay, now first branch will start, and this is the even branch. This will be 0, and at the pi by 2, then this is going to infinite at the pi by 2, but you have odd branch for there. And as this is going to infinite at pi, so this will be at pi by 2, this will be at pi. So you have again even case, and again you have odd case. That will be 3 pi by 2, isn't it? And so on. You can have different values. Now we will just talk about the bound state, and you will just talk about bound state, and we can just think, we can just analyze which one is the odd and which one is the even. So if there is a condition that r is between 0 to pi by 2, so this is the first case. If r is between 0 to pi by 2, then how many bound state is there? Only one bound state, and that bound state is 1 even plus 0 odd. You can just check it. I am talking about this kind of situation. So you have only one bound state that is even. If it is cutting to the even, then you have only one bound state. Now, if I have this much of condition, and please, this condition will come when r is going to change. So at once you have only one particular curve. So here r is between, let's pi by 2 to 3 pi by 2. So how many bound state? You have two bound state. You can have pi by 2 to 3 pi by 2. Means I am talking about this type of condition. So this will be ground state. This will be first excited state. So you have one even and one odd. Next one, if you have r is between 3 pi by 2 to, sorry, r is between, sorry, 3 pi by 2 to pi. Sorry, this will be pi by 2 to pi. And here it will be pi by 2, sorry, pi to 3 pi by 2. Sorry. So this will be r is between pi to 3 pi by 2. You have basically three bound state, and that will be this type of condition. So you have first, this is your ground state, this is your first excited state, this is your second excited state. For this particular case, this is your ground state, this is your first excited state. For this particular case, you have only ground state. So this is my first case, this is my second case, this is my third case. So this is my first case, this is my second case, this is my third case. And you have three bound state. That means you have two even plus one odd. You can just find two even means this is even, this is even, this one is odd. So you can find all this concept from this curve. So whenever in the examination this type of problem will come, what you will do? You will just start from here. You know these two things, and you will just draw this curve, and you will just find how many bond states are possible. If you have any doubt, you can just ask me. So we can just analyze what are the difference between finite potential and infinite potential for the same width. So let's try to figure it out. What are the differences? So is that everybody okay with this? Okay. So let's go for a difference between finite potential and infinite potential. So this is the finite potential for the same thing I am taking minus a by 2 to plus a by 2, and this is the finite one. This is infinite one. This is finite one. Minus a by 2 to plus a by 2. What will be ground state function? The ground state function here is something like that. You remember? This is cos pi x, isn't it? But here you can have this kind of situation. So, and you can, for the infinite potential box, how many energy level you can find? So I am writing for infinite. For infinite, how many energy level you can find? Infinite number of energy level. Number of energy. And for finite, number of bound state is depends on what will be V naught. Number of bound state depends value of V naught. But here you have infinite potential, so you have infinite number of bound state. Both have discrete energy level. You can easily find that both have discrete energy level. Suppose I have this kind of situation. Suppose this is the case. This is your ground state. This is your first excited state. So these are discrete. Both are discrete level. But yes, discreteness is going to change here. But discreteness is proportional to n square. So En is proportional to n square. But here you cannot have this kind of algorithm. It will depends what will be your potential. So En will depends on V naught. But most important thing, so this is the first difference, this is the second difference. And what is the third difference? The particle is confined inside this box. You cannot go beyond the box. But here there is finite probability that you can find the particle outside the box. So particle is confined between x is between minus a by 2 to plus a by 2. So particle, so ये नजर नहीं आ रहा है ना? So particle is confined between x is between minus a by 2 to plus a by 2. But here particle can be tunnel down outside this box. Particle can tunnel down outside the box. So in a classical, these all are classical forbidden region. So even if these are classical forbidden region, you can find the particle outside this box. And this effect is also known as tunneling. So you have finite probability that particle can find outside this box. And now, just give me answer. If this is your infinite potential box, what will be your ground state? Suppose this is minus a by 2 to plus a by 2. This is your E naught. This is your ground state. And if I am going for the finite potential box, what should be ground state? It will be same or different or greater or lesser. Can anybody tell me? What should be ground state? It will be remain same, greater or lesser. Suppose I am talking about finite potential. Can anybody tell me? For the finite potential, it should be, what is value of E naught? Pi square h cut square upon 2 ma square. So it should be same, greater or less than?
Less.
Hmm? Look at here. How we can analyze this thing. So you can find, this is the case. We have eta versus I, and this is the case where you have pi by 2. Eta is equal to pi by 2. Okay. And suppose second will be start from pi. This will be start from pi. Okay. And now, and this will be, second will be start with pi by 2. You can just, this is not pi, this is or this is for the even. And you have exactly from pi, you have second branch. Now, if you have any value of energy, you can take any value of energy and any value of potential, what you can find? This ground state, all are the ground states for the different value of potential, different value of V naught. So always you will find this ground state value will be always less than V naught. Sorry, less than pi by 2, isn't it? The value of R will be always less than pi by 2. So if R is always less than pi by 2, because if R is equal to pi by 2, then you have started to the second bound state. So R is always less than pi by 2. And what is value of R? The value of R is equal to m V naught a square upon 2h cut square. Must be always less than pi by 2 to the power half. So you can find the value of V naught. The value of V naught is equal to, just you can square it, you can find pi square h cut square upon 2 ma square. What is this particular value? What is this particular value? This particular value is E naught, isn't it? This particular value is the E naught, which will be corresponds to ground state. Pi square h cut square 2 ma square. So now, if V naught is equal to pi square h cut square by 2 ma square, if I am taking this equality sign, means you are going to start the second bound state. If I will take this equal sign, then you will get the second bound state. Means the ground state will always less than this particular thing. What is meaning of that? Meaning of that, if I have finite potential exactly like this, then you have the ground state something like this, and you have first excited state something like this, isn't it? And now, if energy is going to increase, if energy is going to, suppose I am increasing the value of V naught, I am increasing the value of V naught, this is going to closer to pi by 2, but it will never reach the pi by 2. Unless until this value will never reach the pi by 2, you cannot get exactly same energy eigenvalue as E naught. So what should be answer? The corresponding ground state will be same or less or greater. What I am saying that you can see here that this is the ground state and it will be equal to, if this will equal to pi by 2, then only you can get the value of E naught. But this is always what? Less than pi by 2. You will never reach, this is pi by 2. So what will happen? The corresponding eigenvalue, for finite potential is always less than infinite potential. So you can make a statement. Corresponding eigenvalue for finite potential, and this is energy eigenvalue actually. Energy eigenvalue for finite potential is always less than infinite one. For same width. So you can have, so for the ground state will be always less than ground state of infinite potential. The first excited state will always less than first excited state of infinite potential. Means if it will be pi square h cut upon 2 ma square for the infinite potential, that will be surely less than this. So what will happen if you will compare these two things? That will be for the finite potential, this will become up to some different level. Suppose this is my infinite potential, this value is E naught, and this is your ground state, then for the finite potential, this value will be surely less than E naught. Whatever be the value of E naught, it will unless until go to infinity, it will not unless until go to infinity, you can have, then only you can have this value is same. So this is the ground state for the finite, and this is the ground state for the infinite. So these are the difference between finite potential and infinite potential. So if you have any doubt, you can just ask me. Suppose you will get 2 electron volt for the infinite potential, then for the finite potential, ground state will always less than 2 electron volt. It may be 1.999 electron volt, but it will never reach the 2 electron volt. That's it. For first excited state, suppose you have some next level of energy, suppose you have 4.5 electron volt, then for the finite potential you have always less than 4.5 electron volt for the first excited state. So why I am using the word corresponding. Okay, for the word I am using the corresponding energy eigenvalue. If you have any doubt, you can just ask me.
सर आपने फाइनाइट के केस में एक कर्व बनाया था बीच में पोटेंशियल वेल में, वो कैसे बनाएंगे?
क्यों नहीं बनाएंगे? कर्व क्या बनाया था? वेव फंक्शन को प्लॉट किया था ना।
हाँ, वेव फंक्शन का
तो
वो
ग्राउंड स्टेट का क्या होगा? ग्राउंड स्टेट के लिए आप प्लॉट कर लो। ग्राउंड स्टेट के लिए क्या था? इस साइड e टू द पावर x था, e टू द पावर गामा x, यहां पर cos e टू द पावर माइनस गामा x, नहीं, e to the power gamma x, this will be cos kx e to the power minus gamma x, isn't it?
ओके सर, ओके।
ठीक है, फर्स्ट स्टेडी स्टेट के लिए क्या होगा, यहाँ पर साइन आ जाएगा, है ना?
Yes, sir.
ठीक है, so why these are this thing, you can see the wave function is decaying up to infinity, है ना? So why I am saying that there is finite probability to find the particle outside the well also. Okay, so let's go for semi-infinite potential. That is the final term for the free particle. Same thing we are doing again and again. So let's go for semi-infinite potential. So Vx is equal to infinity if x is less than 0 and equal to 0, is equal to 0 if x is between 0 to a, is equal to v naught if x is greater than a. So this potential is something like this, isn't it? Semi-infinite. This is infinite. This one is v naught. This is 0 to a. Okay. So we have to solve for the bound state. Bound state means energy is between 0 to v naught. So particle is bounded in this thing. So let's try to figure it out how we will. So what we have to solve? We have to solve the three wave function. Can anybody tell me what will be psi 1?
0.
0. X is less than 0. What will be psi 2? What will be psi 2? Free particle. Inside the box, the potential is 0. So they are just free particle. That will be A e to the power ikx plus B e to the power minus ikx. So this will between 0 to A. And you can take the equality sign because continuity is there. What will be psi 3? Can anybody tell me?
C to the power minus gamma.
Very good. This is classical forbidden region, c to the power minus gamma x. X is greater than A. Should we care about parity here? No, because this is all about positive. So you have to care about parity when potential is symmetric about some origin. So you have not care about parity. So this is not symmetric. You can see. So what we have to do, we have to just take the boundary condition at x is equal to 0 as well as x is equal to a. In the last problem, we didn't care for the both boundary because they are symmetric. The potential are symmetric. So let's go for boundary condition. So what will happen? Psi 1 at x is equal to 0 must be equal to psi 2 at x is equal to 0. So what will happen? 0 is equal to a plus b. This implies b is equal to minus a. So what is meaning of that? B is equal to minus a means psi 3. I can write sine or cos. Which function is there?
Sine.
Sine function. So psi 3 will be some, let's say, some c यहाँ d कर दे d sine kx. What should be the next step? Next step, we will just go for psi 3. Sorry, this is psi 2. So we will just go for psi 2 at x is equal to a is equal to psi 3 at x is equal to a. So what will happen? That will be d sine ka must be equal to c e to the power minus gamma a. Isn't it? Because a is the boundary. What will be next one? Next one, we have to just go for differentiability. Because here we didn't care about differentiability because wave function itself is 0. So that is not make any sense. But here you have finite wave function, so we have to care about the differentiability. So how we will go for differentiability? D psi 2 upon dx at x is equal to a must be equal to d psi 3 upon dx at x is equal to a. So what you will do, you will just first differentiate and then put the value. Then you have d k cos ka is equal to c minus gamma e to the power minus gamma a. Is that it is not clear? I am writing here, okay? D k cos ka is equal to, you have c minus gamma e to the power minus gamma a. What will be next step? Can anybody suggest me? You can just divide these two things.
Divide.
This is your equation 1, this is your equation 2. You can just divide it. So once you will divide it, you will just get a very interesting thing. What you will get? You will get k cot ka is equal to minus gamma. What will be next step?
Dimensionless.
Dimensionless.
Make dimensionless. Multiplying with what?
A.
A. Very good. So you will just multiply with A. And now what you can get? You can write eta
Multiply by A.
is, yes, very good. Eta is equal to minus xi cot xi. What is eta? Eta is equal to gamma A. What is xi? Xi is equal to Ka. What is gamma? Gamma is equal to root under 2m V naught minus E upon h cat square. What is K? K is equal to 2m E upon h cat square. What should be the next step? What should be next step?
Eta
Just tell
square
me.
plus xi
Very
square.
good. You will just get to find eta square plus xi square. So you will just find eta square plus xi square. You can just multiply it, and when you will get this thing, I think you will get this value is 2m v naught a square upon h cut square, isn't it? So you can see this value of r is going to change even if width is same. For the semi-infinite potential, the value of r is equal to change. So why I am saying you just look at the boundary condition. Otherwise, if you will see the width, it will be always make the wrong calculation. So use the boundary condition. Now, what should be? So I will just take this as r square. So we can just go for the uh, this particular thing for generalized value of r. What should be next step? We will just go for what? Graphical method to solve the problem. So obviously, this is very simple. The same thing I'm just going to repeat it. So this will start with the cot. So this will start with the pi by 2. Then you will just go for 3 pi by 2 and so on. So this is the thing. And here you have only one type of wave function, that is sine wave function, isn't it? So what should be condition for one bound state? The r will be between, you can see if r is less than pi by 2, there is not any bound state. This is the one of the wonderful thing. So you have to, minimum value of r must be pi by 2. So this will be pi by 2 to 3 pi by 2. So this is for one bound state, and this is the condition. What will be two bound state? Condition for two bound state, that r is between 3 pi by 2 to 5 pi by 2. You can have next one is for 5 pi by 2. So this will be your second bound state. So this is all about this particular condition, isn't it? So you can just revise this thing. And now tomorrow we will solve the problems, only problem whatever we have done into last 1 week as well as for postulates. So tomorrow we will just going to solve problem starting from the free particle to this semi-infinite potential. So every type of problem we are going to encounter into tomorrow's class. So I request you at least go and see all the postulates. Okay, so just see the postulates, then we can just revise all type of problems. Okay, so if you have any doubt you can just raise the question, otherwise I am leaving the session. Just do the revision, please. The class is more than enough, but revision is very important. At least you have to do all this thing with yourself.
सर थर्ड बाउंड स्टेट के लिए 5 पाई बाई 2 से 7 पाई बाई 2 होगा।
हाँ बिल्कुल 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 ठीक है। अभी प्रॉब्लम करेंगे तो और भी ज्यादा आपका ब्रेन ओपन होगा, क्यों डायमेंशनलेस किया, इसका क्या वैल्यू है, ये सारा चीज समझ में आएगा जैसे प्रॉब्लम शुरू करेंगे तो, है ना।
ओके सर,
है ना, सारा चीज आप एक क्लास और मुझे दो, फिर आप देखो सारे प्रॉब्लम हम कर पाएंगे। ठीक है
सर, वेव फंक्शन प्लॉट कर दीजिए।
वेव फंक्शन प्लॉट कर लो, क्या बात करती हो, जस्ट यू कैन प्लॉट द वेव फंक्शन। ग्राउंड स्टेट के लिए कैसा होगा, ऐसा नहीं, साइन फंक्शन, दिस इज साइन, दिस इज e टू द पावर माइनस गामा x, ये सब तो खुद प्लॉट कर लोगे नहीं। व्हाट विल फर्स्ट एक्साइटेड स्टेट, इस तरह से जाएगा फिर इस तरह से चला जाएगा, इजंट इट।
ओके सर।
सो इफ ओके दिस काइंड ऑफ थिंग। आपने ऐसा पोटेंशियल यूज किया होगा, कहाँ यूज किया है जरा बताओ तो। कुछ तो आपने किया होगा कहीं पर।
सॉलिड स्टेट में।
सॉलिड स्टेट में कहाँ कर लिया तुमने। बहुत इंपॉर्टेंट टॉपिक है आपके एग्जाम के लिए, कहीं पर तो इस तरह का पोटेंशियल किया होगा और कुछ देखा होगा, एनालाइज किया होगा। ड्यूट्रॉन प्रॉब्लम
सभी नहीं किए।
अभी ड्यूट्रॉन प्रॉब्लम नहीं हुआ है, न्यूक्लियर फिजिक्स
हो गया सर।
न्यूट्रॉन कुछ इसी तरह का वहां पर आपके पास पता चलता है ना, क्यों उसकी एनर्जी रहती है बाउंड स्टेट के लिए, क्यों लूजली बाउंड है, ये सारा चीज आपको इसी पोटेंशियल से पता चलता है इफ यू विल गो फॉर द 3 डायमेंशन थिंग। बट फिजिक्स इज दिस ओनली। Anyway, so I'm not going into nuclear physics, just try to understand with the quantum mechanics point of view. So we have finished all type of potential that is for the free particle actually. क्या क्या किया, पहले बिल्कुल फ्री छोड़ दिया, फिर इनफिनाइट करके कन्फाइन किया, फिर फिनाइट कन्फाइन किया, फिर एक तरफ फिनाइट किया, एक तरफ फिनाइट, एक तरफ इनफिनाइट किया, दूसरी तरफ फिनाइट किया। तो ये तो 4 पॉसिबिलिटी है। नाउ वी विल सॉल्व द प्रॉब्लम्स, हाउ वी विल अप्रोच डिफरेंट टाइप्स ऑफ प्रॉब्लम, ये हम देखेंगे। ठीक है।